the SaMMF virtual seminar series in the new year. I wish you all a happy new year, and I hope you all had a nice winter break. So today we are very happy to have Ilse Lindenlaub from Yale as our speaker, and an excellent list of panelists as you see in the screen. And in addition to the panelists you see in the screen, we have also additional panelists from the list of organizers and the board. So we are gonna follow our standard format, which is during the first 1 hour, it's gonna be like a standard seminar, and only panelists are gonna be able to ask their question during the first 1 hour. But after the talk ends, basically we are gonna have a 15-minute Q&A session in which everyone can ask questions. And also we have a written Q&A feature. If you would like to ask your question in a written form during the talk, you can write your question there. So basically that's what we are gonna do for today. And as is typical, we are gonna continue our seminar series bi-weekly. Our next speaker, Maureen O'Hara, is gonna present exactly 2 weeks from now. And we also have occasional workshops. And our next workshop is Mad Money workshop. That's gonna start on February 10th. And if you are interested in learning more about our seminar series and the workshops, you can check our website, sammf.com. So without further ado, I'm gonna turn it over to Ilse. So Ilse, please, you can share your screen, and you have 1 hour.
Thanks so much. So I think you need to unshare. Okay. Okay, all of you can see my screen, right? Okay. Well, thanks so much for inviting me. I'll present the worker job surplus.
We can't see your screen.
Sorry, I cannot see either.
Okay. Then let me do this whole thing once more, because I think. Okay, here. You can still not see anything, right?
I can see it, but it is not in full screen.
Okay, so you can see it because it's.
Yeah, and it was in full screen a moment ago.
Yeah, okay, let me go try to do this again. Now
Perfect.
Okay. Well, again, thanks so much for having me. I'll present the worker job surplus. This is joint work with Fabien and Postel-Vinay, who just told me he couldn't make it. To set the stage for this talk, let me introduce right away the object that's at the center stage of this paper, the worker job surplus. So we're going to be concerned with this surplus of a match XY, so sigma of XY, where X is a vector of observable worker characteristics and Y is a vector of observable job or firm characteristics, which is defined in a standard way as the sum of worker surplus and job surplus, or in other words, as the value of a match, P of XY, minus the outside option of a worker, the value of unemployment U of X, minus the outside option of a job or firm, value of a vacancy, V of Y, even though this, as you will see in a second, doesn't play a major role in our framework. And the main question of our paper is, which are the elements of X and the elements of Y that are really surplus relevant, as opposed to just characteristics that workers and jobs may have, but do not really impact the surplus. And I will make tight in a second what we mean by surplus relevance. So in more detail, what we do in this paper is to try to tell apart the traits that matter for surplus from those that don't. And the way we're doing this is we're comparing job-to-job mobility choices across individuals. That's at the heart of what we do. We develop a theory-based test or method that is based on this idea to find the surplus relevant attributes of workers and jobs. We then implement the method on simulated data to make sure it works, and then I'll show you how to implement it on real data. And it's important to note that this theory-based method does not only guide us in how we should set up the empirical specification that lets us answer our question, but it also allows us to interpret the output of this method in a tight way. Now, why are we interested in this question about the surplus relevant heterogeneity? I'm going to argue that knowledge about surplus relevant attributes is important for many applications. So for instance, if you're interested in structural modeling of the labor market and ultimately in quantification of mismatch and the welfare cost of mismatch, it's important to specify the heterogeneity of workers and jobs in the right way. And hence it's important for ultimately designing policies that reduce mismatch and improve match quality. And this is an exercise, a structural exercise that we follow in a companion paper where we show that correctly specifying heterogeneity is important for these exercises. An application that I will follow in this paper, which is less structural, is that I show that the method and output of our method can be used to define the boundaries of the economy's distinct labor markets. Properly defining the economy's labor markets is important for many applications, for instance, to see which segment of the labor market is hit by recessions or structural change the most. And it's also important for properly quantifying the local labor market power of firms. So I'll try to get at the end of today's talk to this application of how we can use our results to find the economy's distinct labor markets. So that's what we're doing in this paper. And unless there's questions about sort of this roadmap, I'm going to jump right into the framework. So here's the setting we're thinking about. It's going to be an infinite horizon setting in continuous time. There's two types of agents, jobs or firms. So we refer to them as jobs because that's really what we see in the data later. Each job is characterized by a bundle of observable attributes, Y. So there's a vector of things. You can think of this as incorporating any characteristics that we observe about jobs or firms that might be relevant for the surplus. So these could be skill requirements. So for instance, Y1 could be cognitive skill requirement, Y2 manual skill requirement. These could be amenities. These could be characteristics about the firm, anything we observe and that it could be potentially impacting the surplus. We assume that these Ys are continuously distributed according to a continuously differentiable CDF big gamma with strictly positive density little gamma. And on the worker side, we have a similar structure. Each worker is characterized by a bundle X. This X is a vector of characteristics. Again, this could be a bunch of different skills, but this could also go much beyond that and indicate preferences for certain amenities. For instance, anything that we observe that we might think impact the surplus. And these X's are also distributed according to a continuously differentiable CDF. Now, workers could be unemployed or matched to a job. When they're matched to a job, so for instance, if worker X is matched to job Y, then the surplus associated with this match, as I referred to a couple of slides ago, is sigma of XY. And well, this is really the object we want to learn about in this paper. So we don't want to make restrictive assumptions on it ex ante, but we need a couple of regularity assumptions to prove the results of the paper. And the main one is the following. We assume that for all X, sigma of X as a function of Y is a quasi-concave Morse function. Now, I'm not going to come back to this assumption in this talk. It's there for technical reasons. So quasi-concavity ensures that the level sets of sigma are well behaved, and a Morse function is a function that has only isolated critical points, and that helps us to discipline the zero sets of functions that depend on sigma. So I mentioned it basically for completeness, but I'm not going to go into the details of the proofs in this talk for why we exactly need those. Now, in terms of preferences, everyone is risk neutral.
Ilse, can I ask one question on this? So on the first slide, you said X and Y are observable. Is that, yeah, so that seems very strong, that you can observe all the things that go into the surplus function. Will you comment on that at some point?
I'll come back to that at one point. I mean, mainly in response to questions on your side. So it is a strong assumption, and I'll review sort of the 2-3 assumptions that we think are strong or cannot really dispense with in a couple of slides from now. So our, it might become clear, but sort of the purpose of our exercise is, let's do something different from what the literature is doing, which is usually reverting right away to unobserved heterogeneity. And let's first try to learn about the surplus in terms of observables, not denying that there is unobserved heterogeneity, but it's sort of the reverse exercise. And we think that after learning about the observed heterogeneity, we might then go back at some point to unobserved heterogeneity and see what is it what we still cannot explain. But it's right, it's correct that it's outside of the scope of what I show you today. I will I might come back later to a point where I say there's one way of how we can incorporate unobserved heterogeneity, but it might not be the way that you have in mind. Okay, but it's true. It's an assumption that we right now do not dispense with.
So I had some similar ideas, or some thoughts that what you think about some max specific productivity terms, for instance, which you can think of as like amenities, or how close you are to the job or something, which is this, I guess you can also think of as a special case of what Rob says. So that's something that, excluding that, is that important for your empirical analysis?
Yes. So I lay out the assumptions under which our method works, and we can discuss a little bit further about how we can relax some. So some of them are not critical, but the ones, the one that both of these comments go towards, which is that there is observed heterogeneity that is sort of stable across matches. That's an assumption that we make. Yes. So another,
just to follow up on that point, that so therefore also it's important that the X's and Y's don't change over time.
Yeah, they're invariant. Mm-hmm. So I'm not too uncomfortable with that in light of our current empirical application, where we look at a panel of 4 years or so. So it's not an entire life cycle of that would render this assumption particularly problematic. But yes. Mm-hmm. Another important assumption we're making is that we're in a world of transferable utility, and as you will see in a second, this is crucial. Another crucial one, it implies that workers and jobs are joint surplus maximizers, and you'll see how that drives mobility in our setting, and we rely on this heavily. So to wrap up the description of the model, let me briefly talk about this mobility and job search. So in our world, both employed and unemployed workers are searching for jobs. So we're focused on the employed. So let me go into more detail there. Employed workers sample jobs from this job distribution that I introduced. We also call it the sampling distribution gamma at Poisson rank lambda 1. And they accept any job that yields a higher surplus than the current one. And they lose their jobs at an exogenous rate. Unemployed workers have a similar search behavior, but as I said, we're not focusing on it. So let me just say they accept any positive surplus jobs. Jobs or firms play a passive role in this economy that we're depicting here. There's no vacancy posting decision, no free entry. So they're really, you can think of these jobs as sitting passively in this job sampling distribution. They get drawn with replacement. So you can, another way of saying this is that firms or jobs have no capacity constraint. They take on any worker that yields a positive surplus, and they operate under constant returns. So that's our setting as far as jobs are concerned. So to summarize, mobility choices are purely driven by surplus and surplus comparisons. So by our sigma. This is particularly convenient because sigma is a scalar that drives these decisions, even though it's aggregating potentially very multidimensional and sort of complicated heterogeneity X and Y, but it's a scalar that determines these mobility choices. So to recall a worker of type X who's currently in type Y job accepts any job offer Y prime if the surplus with Y prime is larger than the surplus with Y. And then for completeness, an unemployed worker of type X accepts a job offer Y prime if the surplus is positive. Okay.
Ilse,
Now,
can I ask you a quick question? So the arrival rate of offers is going to be independent of the type of job. And
yes,
the type of,
and that's another important assumption. So in 2 slides, I'll review the 3 assumptions that I think are sort of important that we currently do not know or we haven't worked much on relaxing those. And so it's hard for me to say whether it's possible or not. Yeah, but that's an assumption we're making. So I want to, after having laid out this framework, tell you sort of in, more formally what we're after about finding out these surplus relevant skills and job characteristics. So the attributes that I introduced, these X's and the Y's, I want to actually call them potentially relevant attributes on the worker and the job side. But we believe that the world is probably more parsimonious than that, and that only the first XR are for relevant elements of vector X, and the first YR elements of vector Y are really surplus relevant. So the other characteristics workers and jobs may have, but they do not necessarily impact the surplus. Now, how do we define surplus relevance? We say that a skill or a worker attribute K is surplus relevant if the partial derivative of the surplus with respect to xk is not 0 for some xy set of positive measure. Okay, so similarly on the job side, a job attribute yj is surplus relevant if the partial derivative of sigma with respect to that attribute is not 0 around some point. Okay, and we denote the surplus relevant attributes by xr, so this is a vector potentially xr and yr. And what we're after in this paper, and this sort of clarifies, what I said in the introduction, but now using the notation of the model, the main objective in this paper is to learn about the relative inputs to the surplus function. So we want to learn about sigma as a function of xr and yr, as opposed to just sigma of x and y, so taking all the observables into account that we have, and opposed to the approach that, with very few exceptions, the literature has been following, which is to assume that sigma is a function of x hat and y hat, where x hat and y hat are unobserved scalars. Okay, so we're focusing on the observable party of the surplus function, and we allow the dimensionality to be larger than 1, and let the data speak about that. Now, wrapping up, and questions came up about.
Just ask a question here. So there's like a difference between a characteristic making the surplus positive versus what you're defining as surplus relevant. No, because as an example, if you thought about like take education, that could be something that makes surplus, positive. But then if you're looking at, mobility decisions, if you have a world where education is like, somehow additively separable in a surplus function, it's not going to matter at all for where people move to. So would that still be a surplus relevant characteristic?
So if it impacts, well, in our world, as you will see, and that will be the main result that I'll focus on today, if mobility depends on that attribute, education, you said, then it will then we will interpret it as a surplus relevant characteristic, and that's true based on the assumptions that we're making here. And I'll show you that result. So maybe we can, if the proposition I show you doesn't clarify the point further, we can come back to that. But yes, so it will. Yeah, let me postpone that because that already comes to linking what I'm telling you about here to the mobility, and that will be the content of the main result I'll present. So just to wrap up this description of the model and recap the important assumptions that currently I'm not sure we can relax. So it has come up, the question about observable versus unobservable. We assume that X and Y are observable. We assume that we're in a transferable utility world where agents' mobility decisions are driven by surplus maximization. And another thing that has come up, we're assuming that the job finding rate λ1 is independent of X and Y. Here we have some conjecture but haven't worked it out fully that we can make, we can allow for dependence of lambda 1 on x's and y's through endogenous search effort, which is also driven by surplus, but we haven't worked that out yet, but it's on our radar. Okay, so these are the important assumptions that I'm currently not sure we can relax, and under those we establish the main results.
Now, random search is also implicitly an assumption in there, so that all x's are equally likely to draw the y's from the same distribution gamma.
Yes and no. So we can accommodate some directed search environments. So for instance, I think Espen has a paper with Garibaldi and Sommerfall where we have a directed search environment with a continuum of types where there exists what's called pure job ladder, in the sense that any two workers who have currently the same surplus target the same submarket and hence surplus through on the job search. And in such an environment, what I will show you will still go through, because two workers who are alike and who have currently the same surplus are in the same job will have the same E to E transition rate, which I'm going ahead of myself now, but which will be the main thing we look at in the data and will thus pin down the surplus relevant characteristics. So that environment we can accommodate, but there's other directed search environments that might play out differently with indifferences between different submarkets that you're searching in and so on and so forth, and that would be more complicated. Now, before I go to a formalization of our main methodology, I wanna explain to you the idea that underlies this methodology. And the idea is relatively simple. So,
question, going back a slide.
Yes.
In the case you just described with directed search, why is lambda constant across all the submarkets?
Is not, but that would be a special case where it would still work.
I see. Okay.
Yeah. So, and I'm happy to discuss a little bit more after, maybe about the directed search. So the idea of our method is intuitive and simple. So in our world, workers move from lower surplus to higher surplus jobs, okay? But then observing individual mobility decisions and observing the worker and job traits that these decisions depend on should inform us about the surplus relevance of these attributes, okay? So let me say this one more time, because this is really at the heart of what we do. So mobility decisions are driven by surplus comparisons, but surplus is not something we observe, but we would like to learn about it. But then we observe attributes that these mobility decisions depend on, and that will let us indirectly conclude about properties and surplus relevance of these attributes. Okay, so to make this a little bit more concrete, let me first walk you through a simple example, and then I'll go to the main theory result that I want to show you today. So I'm going to walk you through a two-dimensional example where workers have two potentially relevant attributes, call them cognitive and interpersonal skills, X1, X2, and jobs have two potentially relevant attributes, call them interpersonal and cognitive demands, Y1, Y2. And the question is, which of these worker and job attributes matter for the surplus? So for instance, on the worker side, is XR the vector of relevant, or the set of relevant worker characteristics, is it composed of X1, X2, or only of X1, only of X2, or of course, one option would be of neither. And similarly on the job side. So what situation allows us to address this question? We're considering two workers here with the same cognitive skills, X1, but they differ in interpersonal skills, X2. And they're currently in jobs with the same cognitive skill demand, Y1, but these jobs differ in Y2. Now, if only the first dimension, this cognitive dimension, matters for the surplus, then both of these workers are exactly the same. They should accept and reject the same jobs. They should climb the same job ladder. However, if also the second dimension matters, either on the worker side or job side or both, then mobility across these two workers should differ, okay? They should climb different ladders. Hence, if we compare the job acceptance sets within these one-dimensional types, that should allow us to either validate the one-dimensional assumption or reject it. Now I'm laying out this logic in the sort of case where we try to discriminate between 1- and 2-dimensional heterogeneity, but the same logic applies to testing whether the world is n-dimensional or the surplus relevant characteristics are n-dimensional where n is larger than 1. So this is the idea that we're trying to pursue. So let me now show you.
Can I ask a question about that? So suppose it was x1 plus x2 that matters and y1 plus y2. Would you call that 2-dimensional heterogeneity?
I have that's a good question, and I have a result about when we can collapse this multidimensional heterogeneity into a single index later on. Yeah, so let me come back to that. So in that case, the single index representation would be valid, and I wouldn't call this multidimensional heterogeneity. But our results inform about that case and specifically.
Doesn't that example also not depend on what the search cost is, whether it's additive search cost or whether it's discounting? So whether or not you can collapse. There's the ATACAN result that gives you different kind of conditions for sorting. This is in one-dimensional versus the raw.
Yeah, not in our world. So I'll show you actually not in detail because of this being a short talk, but I summarize these results on the implications of what I do here for sorting and the single index representation for you. And I show you the conditions that we need or what it depends on. It doesn't depend on how the search costs are specified. It doesn't depend on search costs.
Thanks.
In the framework where we laid out. I mean, yeah. So let me now try to formalize this intuitive idea. One tricky issue here is that the job acceptance sets that my example relied upon is not observable in common data sets. So we proxy it by something that is observed, namely the job-to-job transition probability that we call tau. So tau of xy is the probability of worker X currently in job Y to transit to a higher surplus job Y prime. Yeah, and it's defined in the usual way as the product of the job arrival rate lambda 1 times the probability of accepting the job offer that comes along, which is the case if this surplus with a new job offer Y prime is larger than the current surplus. Yeah, so that's the key object that all of our results will attack. Yeah, and before I show you the main sort of the backbone of our method, I want to introduce one definition because this property, the single crossing property that I'm now introducing, pops up in this result I'm showing you on the next slide. So we say that the surplus function sigma has the single crossing property in attributes yi, yj, and xk locally at some point xy if the marginal rate of substitution in the surplus function between these job attributes yj and yi depends on xk. Yeah, so the derivative of this ratio with respect to xk is not 0 at that point xy. Okay, so for some of you, single crossing might sound familiar. We're usually restricting it to be positive or negative depending on whether we want to specify complementarities in certain attributes or substitutabilities. Right now, I'm leaving this open. I'm just saying single crossing holds whenever this marginal rate of substitution depends on a worker attribute xk. Yeah, so that's just the definition. Now, here is the main result that I'm showing you today. And I just want to reiterate the logic of what we will see in a second. Remember, I want to learn about the surplus function and the dependence of the surplus function on x and y. I don't observe the surplus in the data, but I do observe the left-hand side here. And I do observe in general, I mean, through the means of regressions, what this tau depends upon in terms of x's and y's, and that will allow me to conclude about the surplus relevance of these characteristics. And that's the content of this proposition. So I'll first show you how we can conclude from the dependence of tau on job attributes about how the surplus function depends on these job attributes, and then I will go to the worker attributes. So for this result, I will fix a worker type X. And the result on job attribute says the following: for all y, tau depends on yj, so partial tau, partial yj is not zero if and only if the surplus function depends on yj. Yeah, so relative straightforward the interpretation here. So tau depends on yj, on that job attribute, if and only if that job attribute is surplus relevant. Okay, where we need a little bit more to interpret what the result means is on the worker side. And I'll first present here the proposition, and then on the next slide, I'll spend a few minutes on the interpretation and the implications of that. So on the worker side, we don't have a characterization result, but almost, yeah, it's almost an if and only if. So let me first state the necessity of single crossing for tau to depend on x. So here we have the following: for all y, if tau depends on xk, then there exists job attributes yi, yj, such that single crossing holds in attributes yi, yj, xk, at least locally. Yeah, so in words, it says that whenever we see tau to depend on xk, then we can be assured that that the single crossing property of the surplus function involving xk in some job attributes holds at least locally. And B states the sufficiency of single crossing for tau to depend on xk. Okay, now let me spend a couple of minutes, and that go also.
Can I ask a question, Ilse? Can I ask you a question?
Yes, of course.
So maybe this is a good place to try to understand better why you cannot deal with folding the lambda inside the sigma.
Yeah,
I see lambda bigger makes, or maybe you can, makes it more likely to leave, but on the other hand, it could affect that indicator stuff, right? That's a concern.
Right, so depending on the model, lambda shows up in the surplus function as well, and sometimes it doesn't, so that depends on other, further assumptions that we would need to make, especially about the surplus splitting protocol here. But as you see, if lambda depends on x and y, we may not be able to conclude anymore that the dependence of tau on x and y is driven by surplus as opposed to lambda. So it could be both. I mean, it could be that it's driven by lambda and lambda is in the surplus function, but without, there are models where lambda doesn't depend on, doesn't enter the surplus function. So for instance, the sequential auctions model without worker bargaining power is like sort of one of the workhorses that is used in this literature. The surplus doesn't depend on lambda. So there, we would not be able to conclude whether the dependency of tau on x and y comes from the lambda or whether it comes from the surplus. That's the sort of the difficulty we're facing. But that's a good point. So here you see it clearly on this equation. Okay. So I want to, as I said, spend a couple more minutes on the interpretation of the result, coming back to some of the comments that were made before. So on the job side, it's relatively straightforward, and I mentioned this already. So whenever we see in the data that this E to E transition probability depends on some job attribute yj, we can conclude that yj is surplus relevant. On the worker side, there's a similar implication, but there's more, okay? So on the worker side, if we see tau in the data, this E to E transition probability to depend on some worker attribute xk, then we can conclude that single crossing holds at least somewhere locally, and that clearly implies that xk is surplus relevant. So that basically, these two parts already answer sort of the main question that we set out to answer in this paper. But interestingly, from this single crossing condition being necessary for tau to depend on xk in the data, we get further implications out of our potential test results. In particular, we show in the paper, and I'll just summarize this now for you here, that single crossing is necessary and sufficient for xk to be sorting relevant, where sorting means that different workers who differ in xk have different job distributions in steady state. this might not, again, is not that easy to show, but intuitively it makes sense if we think of complementarities or substitutabilities being encoded in this single crossing condition, that single crossing leads to sorting as sort of an intuitive outcome. Furthermore, and this goes back, I think, to Rob's question, we can show that whenever the single crossing condition that I've defined holds at least locally, there's no single index representation of the surplus function of multidimensional heterogeneity that enters the surplus function. Where we define the single index representation as a redefinition of the surplus function as a bivariate function of a worker index that summarizes all the underlying multidimensional worker heterogeneity. So the x1 plus x2 would be an example, no? And 1D job index, such that the surplus function is intrinsically the same as before. So we don't lose any information. We don't change the value of the surplus for any XY match, but we can change this representation and express the surplus function as a function of these two single indices. And we show that single crossing prevents that single index representation. And the intuition is the following. So single index requires that the marginal rate of substitution between y1, yj, and yi in the surplus function is independent of worker type. So it basically requires that all workers in the economy trade off different job attributes in the same way. Yeah, and this trading off things in the same way will lead to a uniform ranking of jobs across all workers, and hence allows for the single index representation. But whenever single crossing holds, this marginal rate of substitution precisely depends on worker skills, and this invalidates the single index representation. Okay, so as a byproduct, even though not our main result, as a byproduct of our method, we get, sort of important implications about the sorting relevance of attributes, as well as whether multidimensional heterogeneity can be collapsed into a single index. Okay, so overall, these results, or this result that I've been focusing on, and the ones I've been telling you about, allows us to go essentially back and forth between something we want to figure out. Okay, so the surplus properties of the surplus function, in particular, surplus relevance of the attributes, and something that we can observe in the data, which is tau and the dependence of tau on these workers and job attributes. Yeah, so that's what our theory allows us to do. And based on this result, we're specifying an empirical model of the E to E transition rate as follows. So this is here in equation 1, where we postulate, or we approximate essentially the conditional mean of this tau based on this linear function of the potential x's, the potential y's, and the potential interaction terms. We also have results on these interaction terms, what's the implication of tau depending on interactions, but I haven't shown them to you because it's just more of the same thing. Okay, so that's the empirical model of the E to E rate that we're going with. Index I is an individual, and tau is an indicator that is either 0 if there was no job-to-job transition between t minus 1 and t, or it's 1 if there was one. Okay, and what I'm going to do with you now, or show you now, is that we can use model selection methods to identify, based on this empirical model of tau, which of the x's and y's are surplus relevant. So we can identify the xr and yr as those attributes who significantly impact the tau, while sort of optimally trading off the goodness of fit of this regression versus the problem of overfitting. Okay, so now would be a good time to ask any questions about the theory.
Ilse, can you think of this as a form of revealed preference, in the sense that you see individuals' actions or choices and you infer that? The difference here is that what you infer about is an endogenous object. It's a surplus. It's not like this the production function, if you want, or the match surplus function. It's the value function, the surplus of it. But
yeah, it's clearly related. Yeah, it's clearly related to the logic of revealed preferences, revealed through the mobility choices. Yeah, clearly. because this allows us to see sort of how these trade-offs between different jobs are made and how different workers make them differently. That's at the heart of what.
So Ilse, if I found that people with, and it's kind of going forward a little bit, people with high levels of like interpersonal ability were better at interviewing and better at finding jobs, I guess that would show up here as a positive beta, estimate of beta. And then I would take that, and using the theorem, I'd say I've kind of rejected a single crossing. Sorry, we have this single crossing property, but again, it's nothing about the single crossing property itself. This is about like having different levels of different rates of matching. I know we keep on kind of coming back to this. But
right. So that comes back to it's an important point. I at the moment I can only say I'm maintaining that assumption that the way I interpret your comment is that this basically affects the lambda workers with a higher X. I don't know if you said interpersonal skills might get more offers. And again, so I'm with you that that's a case that would yield potentially wrong conclusions. But it's it's excluded via our assumptions, and I'm just trying to be clear on what the assumptions that we need in order to interpret things in the way I described to you.
And then back to something like back to say, oh sorry.
So why is it not enough that in the case that Simon suggested that the worker with interpersonal skill gets more offers, but that's independent of Y?
Well, because we still have, even if lambda 1 depends on X, we still run into a similar issue.
So is the answer kind of, if you could see this, if you were estimating the surplus function directly, you could do that, you'd see it, but using kind of just the transitions, we don't.
Yeah, we only get sort of indirect information about the surplus function, and I want to stress that we do consider it to some extent as a strength of this method that we do not need to go down the structural approach. We do not make as many assumptions as you would need to make if you estimated such a model structurally, and we can still learn a whole lot about the surplus function, within the framework, within the assumptions we're making. And yeah, but these are good points, but they come back to I think to the issue of whether lambda 1 is dependent or not on the X's and the Y. So one thing, that doesn't address your concerns, but there's one way the literature has introduced unobserved heterogeneity, which is through these reallocation shocks that are IID and independent of the X's and the Y. So this would just mean we're adding sort of an IID shock here. Obviously that's possible, because that averages out across agents and hence wouldn't impact any of our results. But as soon as there is systematic relationship between lambda 1 and the X's and the Y's, we need to do more work in order to see what goes through and what doesn't, and I'm not sure. Okay.
Ilse, I have just a related question. In the empirical framework that you show us on the previous slide, how shall we think about epsilon in terms of the model and of orthogonality assumption you might pose between epsilon and
so I think that can be framed in terms of the question about unobserved heterogeneity. So
there's a lot of stuff that could
So and I'm sorry I repeat myself. I might repeat myself here. So it is an assumption that we're making that the X's and the Y's, the potentially relevant ones, are observed. Obviously, we know in practice that's not true. So there's some stuff in the epsilon that might correlate with these X's and the Y's and then generate omitted variable problems. Now, I'm a little bit less concerned about this compared to a case where I wanted to take this regression at face value and interpreted the levels of these regression coefficients, and every bias would be a problem, because we're using this regression simply to do model selection on it. So unless the bias that these unobserved components introduce is so strong as to make some coefficients significant that would otherwise not, or vice versa, we wouldn't have a problem because we don't work with the estimates themselves. Yeah, so that's just one comment about it, that it might not be as much of a problem as in some other contexts, but I don't want to go as far to say it's no problem. And in fact, we're currently we're doing some simulation exercises with unobserved heterogeneity to see whether it's a problem for our method. By the way, I'm going to the empirical implementation now just to talk a little bit about the data in the interest of time. There is a Monte Carlo section in the paper where we really extensively try to see whether our method works on data that we can control, where we can control the data generating process. And it does seem to work well. And we also test across a variety of different model selection tools. There's hundreds of them. So we're trying to figure out which works best in our context. And we take those lessons when we go to the real data. So
it seems like it wouldn't be hard to rig up an example where there was an X that was payoff relevant, but because of selection, the X's who took sort of the unusual job for them. Now I'm adding unobserved heterogeneity now, explain the epsilons. So the X's who took an unusual job for them would have to have such a high epsilon that they would be unlikely to leave that job. And likewise, and conversely, you have some other X and some other Y when they're taking unusual. So it's just going to depend on tail distribution assumptions about the epsilons on the likelihood of or the longevity of particular matches. So I could imagine, I was trying to think about why you can't have unobserved heterogeneity. I think if you articulated that, where things would go wrong in your proof with unobserved heterogeneity, you'd be able to construct examples where the X's are payoff relevant, but things happen to cancel out in exactly such a way that you would miss it through the mobility.
yeah.
I mean, you might see it somewhere else.
Or vice versa. Or vice versa. You could also figure out example where it works. Right?
No, of course, yeah. So in fact, I think it would be kind of borderline to make it exactly cancel out, but it's a little different than, I don't know. I think of, I don't know. I think first attenuation bias or something like that. But there really might be structural models where this would exactly cancel. But by the same token, you would also think that maybe those unusual jobs, you would see it through, say, unemployed workers transition. So maybe you can comment a little on the choice to focus just on job-to-job transitions and not other types of data that you might have?
Yeah, so we discussed this a little bit. So to this last point, Rob, because the previous one, I see the issue, the potential issue with unobserved heterogeneity, and but I'm hesitant to say right now such and such case would work, such and such case would cause a problem because we haven't worked it out. But coming to the point why we don't use other data, so we have specifically thought about UE transitions and about wages, and we analyzed this a little bit in the paper. So in both cases, we come to the conclusion that we would need to make more assumptions and get less information compared to the case when we focus on the E to E transitions. I mean, I can just give you the example of the UE transition. So the UE transitions would also reveal the surplus relevant worker characteristics. So we show that, but because UE transitions do not depend on the current job offer, I mean, these are people coming from unemployment, we wouldn't learn about the job relevant, the relevant characteristics on the job side. And we also wouldn't learn about single crossing and all these implications that follow. Moreover, this would only work if there's marginally beneficial matches in the economy, while our EE method does not rely on that. So we need to make, so we gain less information relying on the UE transitions and would not, based on the dependence of UE transitions on the attributes, recover any more information that we currently do. And we go through a similar exercise with wages, which on top of things brings about the problem of how to specify the surplus splitting protocol that we don't really, something that we do not need to in our current method, and we consider this as an advantage. But yes, so we do discuss these additional, commonly used statistics, alternative statistics, but we came to the conclusion that the EE rate provides us with the most information and needs the least assumptions.
Ilse, can I ask you one last thing about that?
Yeah.
So So in principle, I mean, the theory makes us think about like a job, right? Instead of a collection of jobs at a firm or something.
Yeah,
I mean,
even though you could, so, you know, okay, so there is two sort of camps in this labor search literature or workhorse models that have been extensively used. One is one with a very tight, I guess, capacity constraint on the firm side. The usual thing is one-to-one matching, one firm, one job. And then there is the framework that I'm operating in with a sort of the complete opposite, no capacity constraint. Yeah?
So all I wanted to say is that there may be some information. If you see lots of workers exiting the firm with a wide variety of a particular X, that's maybe information that X is not that relevant for the surplus, or things like that you might be able to exploit if you.
Yeah, and we, you know, like if we had firm data, which in our current empirical application, if I get to talk about it, we don't have. We're using the SIP, which is a worker panel without really firm information. So if we had firm information, you could put into these potentially relevant Ys anything about the firm that you think might matter. I mean, these Ys are not just restricted to, strictly speaking, job characteristics, but they could also encapsulate firm characteristics without any problem. So it's anything that a worker's job, you know, is characterized by, and could be both.
Okay. And the last thing is, if there were something where there's teams effects or peer effects, where would they show up here when you run it empirically? Everybody's leaving a department, so people just want to go. What term would pick it up? Is it? I guess it must be a Y term.
Yeah. Well, I mean, so if you had some productivity of the team or the firm or something where would capture this in part, then this would show up in the Ys. If you don't have that, then it might, it ends up to be unobserved.
Okay.
Yeah. Okay, so I think I have I started probably a couple of minutes late, so maybe I have 10, 15
You have
minutes.
about 12 minutes, yeah.
Okay, so let me briefly talk about how we implement this method in the data. And I should stress that it's really more like a proof of concept. At the moment, we don't have the optimal data to implement it because the panel is relatively short and not as large as we would like to, but we're planning a follow-up paper where we use Norwegian matched employee data to implement this properly. But let me show you what we have. So we use two data sources. On the job side, mainly we use the ONET. Most of you are familiar with that. So it's a data set of occupational skill requirements and amenities. And that will essentially be used to get to our potentially relevant job attributes vector Y. It's not exactly that, because we're also using, and there I'm going back to Ricardo's question, so we do have firm size or workplace size in our main data set, the SIP, even though we don't have firm identifiers, but we'll throw that in as well, okay? So the ONET is basically there to get us the potentially relevant job characteristics. Now, on the worker side, for our mobility, the main data set is the survey of income and program participation. It's a large labor force survey in the US, rolled out in different panels. We focus on the SIP 2008. That's another reason why this application is special. So actually in the paper, we'll also do previous panels, but today I'm going to show you basically the peak of the Great Recession and the recovery phase. So that obviously might impact the results. That's something to keep in mind. But the reason we're using the SIP is that it has this special education and training module that is not much explored. And that module allows us to actually recover the potentially relevant skills on the worker side. So based on degree or training, we're able to define for each worker a vector of potentially relevant skills. So just to give you a sense of what we do. So basically, if I see one of you in the data set and you have a bachelor degree or a PhD in economics, the assumption I'm making is that you're qualified for the occupation economist, and maybe also for other occupations. There's standard crosswalks that link degrees and training to occupations. And then I'm going to check in the ONET what requirements one needs in the occupation, or what requirements, skill requirements the occupation economist has, and I attach those to your skill bundle. And then, I mean, there's more stuff there, but that's the essence of what we do. Now,
so here you have, in a way, a one-dimensional characteristic, which is the education in the data, and you are transforming it into a vector of skills.
Right. So we're working with these, with the larger vector of skills. We could throw in there the education as well, and I think we did at some point in our exploration of this, and it didn't have predictive power over and beyond those more finely grained attributes. Okay, so in the interest of time, I'll go a little bit quick now. So we do some pre-treatment. We have to do some pre-treatment of these potentially relevant worker and job characteristics just to avoid that a lot of them are very highly correlated. That's a feature of the ONIT. The ONIT has hundreds of predictors, but many of them say the same thing. And it's a common pitfall in model or problem in model selection that if the right-hand side variables are 0.9 or more correlated, model selection doesn't work well. So we do some pre-treatment, and I'll skip the details, but we end up in this sort of empirical illustration with 10 potentially relevant worker attributes and 10 plus one because of firm size potential job attributes. And I'm going to implement this E2E model, using model selection via the Bayesian information criterion that has turned out to perform best in the simulations. And we do control for some additional characteristics of workers just to alleviate to some extent the unobserved heterogeneity problem. So we could make these also observables that can be selected, but right now we just control for gender, age, race, marital status, and also for the average monthly E2E rate. Now, just to give you a sense of what characteristics the potential relevant ones are. So here we have the a word cloud of the potentially relevant job characteristics, and I just put some labels based on this pre-treatment of the variables that allows us to interpret these attributes in light of the ONIT descriptor. So we follow the literature in the sense that we have a couple of cognitive attributes: originality, which is non-routine cognitive, and then some routine cognitive. We have a couple of interpersonal attributes: empathy and ability to sell or influence others. We have some manual, we have some job amenities, like whether the job exposes you to hazardous conditions, or whether the job requires you to work long hours. So there's a bunch of these potentially relevant characteristics, and we have firm size, and then we have the symmetric ones, because of the way we construct skills here on the worker side. And our test, or our method, reveals that the model that gets selected is relatively sparse. So on the job side, we have that the disamenity of long work duration matters. One of the cognitive attributes matter, one of the interpersonal, one in firm size. And similarly on the worker side, only that there also the manual attributes get selected. Now, so again, this is more like an illustration, but what do we get out of this illustration? How can we use our theory to interpret these results? Well, first of all, that's what I've just shown you. We get the vector of surplus relevant job characteristics. Here they have the numbers in the entry, and are specified according to the entry in the vector and the original vector Y, and we get also the relevant worker characteristics. But based on our theory, we can now interpret things further. We know that because tau in the data depends on X's, the single crossing property holds. So we reject that there is no sorting in the data. We reject also the single index representation. And both of these things together basically mean that workers of different skill bundles rank jobs in different ways. There's no one-dimensional economy-wide job ladder that all workers agree upon. Instead, workers of different bundles have different job ladders that they're trying to climb. Now, so that's just the literal output and interpretation of these results based on our theory. I think I have around 5 minutes to just briefly talk about one reason why we think these results might be useful. So here I just summarize a couple applications. The first one we deal with in companion paper, where we argue that correctly specifying heterogeneity is important for quantifying mismatch properly. So I'm not going to talk about that now, but here I want to tell you about how we can use our method and the results to define and analyze the economy's distinct labor markets. So the premise here that we're stipulating is that the economy's labor markets are segmented by worker skills and by job attributes. And workers that are similar in terms of their skills could potentially work in jobs that are similar in their attributes. So we're trying to find labor markets in which this potential worker mobility is maximized as opposed to the observed worker mobility. And because mobility is driven by surplus comparisons, our methods can be useful here. Yeah? So it basically says that we should use and focus on the surplus relevant skills and job attributes in order to draw the boundaries of the labor markets in the economy. So we do this in 2 steps. We first use our output from the method that I've been showing you to define worker and job types based on the similarity of their relevant traits. And then in the second step, we use a machine learning technique in order to define the labor markets based on these relevant traits by maximizing the within labor market mobility of worker type. So this is a little bit fast now, and I apologize for that. So I just want to give you sort of a couple more slides on what we do here. So we end up, this method yields 4 labor markets in the economy, and they're depicted in this 3D graph where we plot the labor markets or the job types as a function of the relevant characteristics, work duration, cognitive skill requirement, and interpersonal skill requirement, where we leave out the firm size dimension for plotting purposes. And each dot here is a job type, okay? And a color indicates membership in a certain labor market. And you see from these colored clouds here that there is significant segmentation of the labor markets in terms of the relevant characteristics, even though that's not something that we targeted in the second step of this estimation. And moreover, we go in the paper, in an updated draft of the paper, through a variety of exercises to show that these labor markets that we recover, these 4 labor markets, are different to what people have done in the literature, which is to define labor markets based on occupation or on industry, or by a ranking of wages, or by a ranking of any of these job traits. So these are different from those classifications. And
sorry, Ilse, just a clarifying question. These are the characteristics of the workers, right?
No, of the jobs.
This is of the jobs.
Mm-hmm.
Okay. Are the workers then transitioning across these labor markets?
Yes.
Though? So I guess I was trying to understand.
These labor markets, sorry, I went fast on this, and we can maybe use the discussion.
We can talk afterwards, yeah.
More. But just to reiterate that, so we're trying to find these labor markets such that the within market, within these yellow, green, blue, and green and red job clusters, within those job clusters, the worker mobility is maximized as opposed to across clusters. Yeah. So it's similar to some of the approaches that have been used in the literature, but our first step here is the crucial one, which takes the surplus relevant skills and job attributes into account to define these worker and job types. But I'm happy to talk about that in more detail after. So I basically need to wrap up. So I just want to mention that we go through a bunch of exercises to show that these labor markets are not just empty labels, but they have economic content. They're predictive of stuff that we care about. And I just summarized this one thing verbally here without showing you the regression in detail. So for instance, we find that if a worker is well matched to a market, in a way that I'm obscure about now, if a worker is well matched to a market, so is in the market that is typical for her type, then this is predictive of a reduced separation rate and increased earnings. And we also show interesting stuff regarding wage growth along these and within these 4 different labor markets that you could interpret as the 4 distinct job ladders of the economy. Now I'm out of time, so let me just conclude. So what we're focusing here on is the question how many and which worker and job attributes matter for the worker job surplus. And the main contribution in this paper is to develop a theory-based test that explores worker mobility choices that gets us an answer to this question. Now, it's important to note that this theory-based method does not only guide us in how we specify the empirical model, but it also helps us to interpret the results that we're getting in a tight way. And we're arguing that knowing about which attributes impact the surplus is important for many applications. So I rushed a little bit through this, but I'm arguing in this paper that it can be useful for properly defining the economy's labor markets. And it also is definitely crucial for more structural applications of this type of model. One important one has been to quantify mismatch, and we've shown this companion paper with Fabien that correctly specifying heterogeneity or accounting for multidimensional heterogeneity is important to reliably quantify that. Thank you.
Thanks, Ilse, for the great presentation. So now we are going to start the Q&A session. So we are going to start by taking if there is any more question from the panelists. And if there is no more question from panelists, we are going to move to question from attendees. Okay, I guess we can move with the attendee questions. So on the written Q&A, I am seeing a few questions. There is a question by Eva Moring. So Eva, we are gonna unmute you and you can ask your question.
Hi, I was just wondering whether you could also tell whether the layoff rate, could that be different across workers as well? Mm-hmm. So maybe you can use the transitions from employment to unemployment to do that, for example. And I mean, I guess would be important to take this out from the surplus if you want to think about discrimination across some dimensions. So maybe some group of people or with some characteristics are more likely to be laid off rather than to generate the smaller surplus per se. So it might be relevant to actually tell these two things apart.
Right. I mean, whether the heterogeneity in delta or in the separation rate is due to discrimination or whatever. I mean, independently of that, it shows up in the it tends to show up in the surplus function, and we can accommodate. So that's an assumption. So it's true in the baseline model. I assume that this separation rate does not depend on the x's and the y's, but that's actually something we can relax. So it would just show up as one object in the surplus function that depends on x and y's. But right now we're sort of not specific about what object exactly in the surplus function depends on worker and job heterogeneity. I mean, we might all have in mind the production function, of course, but it could be other objects, and that's something we can accommodate. Now, I haven't your second part of the question or comment was we could use the separation rate as another statistic that gives us information about the surplus function.
Yeah, you could use the transitions from employment to unemployment to tell this apart, right? This layoff probability and the surplus, I guess.
Right, so I will need to, well, we need to have a different model now for why,
sure.
Why there are separations that depend on X and Y,
sure.
So maybe some idiosyncratic shocks or something like that. So I would need to work through that, but in principle, if you have an enriched model like that, it could be that this is a useful statistic to look at.
Okay, thanks.
So if you have any question, you can use the Zoom's raise hand function and we are gonna allow you to ask your question. So Shangjin Zhang has a question. So Shangjin, I'm gonna unmute you.
Yes, so I have a question. So the theory of job ladder with random search would impose, I guess, some restrictions on the regression coefficients. Is it like if the surplus is increasing in the surplus from job is increasing in certain characteristics, then I would imagine the interaction terms between, you know, worker characteristics and job characteristics will be monotonic in like that characteristics. I mean, is it true? And whether does it hold in your regression, like those coefficients?
So I think I agree with the first part of the comment. Not sure if I agree with the second. So I agree that especially as far as the dependence of tau on the job attributes is concerned, we can interpret the sign of these coefficients and conclude about whether these job attributes enter the surplus positively or negatively. But and we did that, and so we can see on the job side at least whether surplus is being positively or negatively impacted by these relevant characteristics. However, I'm not sure why we should be able to conclude from that about the monotonicity of the interaction terms. I'm not sure that's true.
If a job is attractive for a high-skilled worker, maybe it's also attractive for low-skilled workers. So then the transition, it imposes some restriction on the transition probability, especially because it's random search. I don't know.
So, but how is that related? Yeah. I'm not sure about that part. I will need to think. I don't think we can conclude about from the monotonicity. I mean, these are usually two separate characteristics. The complementarity one or the interaction terms vis-a-vis the linear terms. So right now I don't see the connection that clearly, but that might be my ignorance. So I will need to think a little bit more, maybe to verify this. But right now I don't see it.
All right, thank you.
I have one question regarding firm size. I guess maybe in the data set that you have now, you don't have firm size, but if you have, then I guess you will, the firm types will also matter quite a bit for the firm size and firm growth. So to what extent could you use that, you think, to sort of to get more into, to inform your empirical analysis? And also maybe then test this assumption that you have no capacity constraints.
So the question is, to what extent we can exploit more the firm size?
Yes, and also then maybe say something about your assumption about capacity constraint. Firms not being capacity constrained, they are constant returns to scale, I can hire everyone. So I mean, first, both given your assumption, what will you learn from firm size about sort of the productivity of the firms? And then
so maybe we can start with that because that's easy for me. So the reason we include firm size is, so this is the only firm characteristic we observe in the SIP, and we think, and it's been used in the literature as a proxy for productivity, imperfect one, but still. And that's the reason we include it. So we think that matters for the surplus and or potentially relevant, and then the data tells us it is relevant. That's our motivation behind it. I'm not sure we would, so how would you design a test of the capacity constraint? I mean, probably, you know, my prior would be, is most likely wrong, the assumption, but it might not be that detrimental to assume it. Yeah, so, but how would you design a test based on firm size to reject that assumption?
I guess I would guess that if you have some, if you have some characteristics of the firm and from the firms, and from those characteristics you can you can calculate how big the firms should be, how quickly they should grow, and then you could see if that sort of matches the data that you have. If they tend to grow as quickly as the characteristics that you measure them to have would indicate.
Yeah, that's interesting. So, so if, you know, if we have at some point match employee data set with a host of firm characteristics, we can try to dig more into this issue. Right now we don't. I mean, this is not really good. This framework is not really a good theory of the size of the firm or anything. I mean, one needs to be quite imaginative in some sense to say that there. I mean, there is a firm. If you can define a firm, sort of a firm size statistic in this model, but it's not. I mean, it's not a good theory of the firm, and we know that. So I'm a bit hesitant to sort of use the implications of the theory to say something about optimal size. But I agree with your point that we could explore the firm characteristics and the relation of other characteristics to size, etc., much more if we had firm level data, and we plan to do that.
This kind of touches a little bit on something that Laura brought up earlier, but again, it's hard to think about this. I mean, maybe it's just about the language, but the statement of like matters for surplus or doesn't matter for surplus. So as like an example, I had this paper with Violante, Engbaum, and Bilal, where we have firms differ on 2 dimensions, I guess size and productivity and decreasing returns to scale. And like what matters for the level of surplus is the size of the firm, but what matters for sorting of workers across firms is the size and affects the marginal surplus, which is decreasing in the size of the firm. And so you can have one thing mattering in one direction for the level of surplus and mattering in the other direction for the marginal surplus, which is what's leading to the allocation of work, the reallocation of workers across firms. And so I think like to an extent, it seems like the primitive here, instead of being sigma, is really tau. And that, if I write down that expression for tau, I could replace a lot of this, if I believed our model wholeheartedly, then I could replace a lot of the statements here as opposed to surplus, it would be matter for marginal surplus.
Okay, that's easy to do.
But isn't this the same as assuming that the surplus is transferable? In your paper, it's not, which is why you can get the sorting going the opposite way from the total surplus.
No, it's not about the, I mean, essentially ends up being pretty transferable, like transferable. I mean,
but the additional body in your firm means that the
I guess I'm just trying to say, I was trying to say it's more like the you might have something which is different to the level of the surplus, which is determining the reallocation of workers across firms, which is what we're observing, which is the tau.
So like here's an example of, if you take the, let's say in the paper I have with Gregor, if you take the production function where whether or not surplus is positive depends on, like, let's say whether X is greater than Y, but then conditional on that, surplus depends on X plus Y or whatever. In that case, that would be an example where X is surplus relevant, but not marginal surplus relevant, at least when you look at job-to-job transitions, conditional on being employed.
Yeah, so I guess the way I understand these comments is that there might be different ways of thinking about surplus relevance, not only the way we define it, which is that there is a marginal effect essentially of the attribute on the surplus, but there might be specification where surplus relevance shows up in different ways. So
yeah, I mean, I thought it was just a terminology thing before you got to the data exercise, but then you go into like splitting labor markets based on those outcomes, and then it's a little bit less clear whether it is just a terminology thing because you're interpreting it as like mattering for levels. You know what I mean? So it seems to me like then.
What do you
meaning before, like everything was internally consistent, you define surplus relevant as whether or not this tau depends on, or like the marginal surplus which affects mobility rates depends on X and Y.
Yeah.
But there could be cases where something matters for the level, which might determine like what's a distinct labor market, which doesn't actually determine mobility. And one example is just the production function I just gave.
Yeah, so I will need to answer these questions in detail. I would need to see your production function and also the paper that Simon was talking about in more detail. But so I was trying to say under what premise we can use the results that we have in order to define these labor markets, and that is that if we think that labor markets are or should be defined by potential worker mobility, then this is consistent with our approach. Now, if you're saying there might be something beyond that, then I agree, it would be inconsistent. But as long as we stick to this narrative that and the premise that mobility is what should define these labor markets, and the mobility is determined by the surplus relevant characteristics, essentially, then I think it's consistent.
I think it gets icky when you start thinking about, say, my decision to post a vacancy might depend on the level of the surplus, which might be different to what's reallocating workers across firms. But yeah, we can talk more about this stuff as well.
Yeah, but I think these are cases that in one way or another do not fit the framework that I laid out. And the question is should they or can we learn something even though we're focusing on the setting I laid out. But these are good points. I will need to look into more detail into whether we capture them and why not. Thank you.
Thanks everyone for your comments, and thanks again, Ilse, for the great seminar. So now we are out of time, and it looks like there is no more attendee questions, so we can end the seminar.